primarily on environmental controls. So we asked the community to share a little bit about what they're thinking about specifically in the past 24 months and any changes they've made for environmental controls. So hopefully these conversations feel really current. Before we get going on that, we do have a special presentation from Dani Fish. She is a student collections care tech at Case Western. And she was recently awarded an OPC grant to attend the Medieval Girdle Book workshop at Morgan Conservatory. And so she is going to kick it off and give us a little background about that. Dani, do you want to go ahead and share?
Okay. All right. Hello, everyone. I'm Dani. As Amber said, I'm a student in Andrew's lab in the preservation lab at KSL, and I'm also an intern at ICA Conservation with Kate, who's going to be presenting a little bit later. Earlier in the year, I received the OPC Professional Development Grant to attend the Medieval Girdle Book workshop at the Morgan Conservatory. So I'm going to talk a little bit about medieval girdle books and medieval bookbinding, and then I'll talk about the workshop. So medieval girdle books are an extant type of book that was popular between the 13th and the 16th centuries, and they were used for a variety of purposes: religious, legal, and philosophical texts. So as you can see in this little graphic, medieval girdle books had this long leather tail with a knot at the end, and they were used, the tail was tucked beneath a girdle or belt for ease of transport. And as we know, at this time, literacy was not especially widespread, and so this wasn't necessarily an era where people had libraries and collections. They had like one or two prized books that they kept with them that were used for records and religious purposes. So there are hundreds of representations of girdle books in art, but only 23 remain in their original bindings. There are a few speculations as to why this is, but one of the reasons is that as girdle books fell out of fashion and as they deteriorated, there was less and less need to repair them. And so some of them were cut out of their bindings entirely, or they just were thrown away. They were confined to a relatively small geographic region in the Netherlands in the Upper Rhine Valley. So we see some in Germany, Switzerland, some in Eastern France, but they were primarily like this northeastern portion of Europe. So here are a couple examples of girdle books that are in special collections today. I don't have a source for the one on the right, but the one on the left is a German binding, and the one on the right is from somewhere. So you can see they have these knots at the end of their leather tails that were used to keep them in the girdle. The one on the left is interesting because it still shows the original clasps and hardware. On the right, you can see that it was bound with extra leather, which when the book is closed actually wraps around the text block and protects the pages themselves from abrasion and dust, along with the leather tail. So like a somewhat excessive use of leather in these bindings, which was primarily used for protection purposes. The change of bookbinding practices in this era is pretty interesting to study, as you have so many inventions and developments being made in bookbinding practices that all kind of contribute to what we have today, to bookbinding practices that are in use today. So the printing press was invented around 1440, but printing as a widespread practice wasn't completely implemented until the 1600s. And we know we didn't even have steam power until the 1800s. So it was kind of this like slow transition out of very involved bookbinding practices, like what you see with the girdle book, to kind of faster, less involved and ultimately lower quality practices, as you needed to start pumping things out with rising literacy rates and the need and demand for more books to be bound. In this time, you also saw the invention of other printmaking processes like lithography and etching, which all contributed to these changing developments in bookbinding and also to the rise of global literacy. So the workshop was taught in August by Fran Kovac at the Morgan Conservatory, and we went through the entire production process of these books. So we sewed the text blocks, shaped the wooden boards, laced in the cords, and did the entire like leather and covering process. This illustration on the right shows kind of the natural shape of the text block after it's been shown, and then after it's been shaped and pressed onto the boards. The boards themselves are angled at the end. They're not just perfectly rectangular wooden boards. We sanded them so that they fit nicely against the text block, and this prevents abrasion by the boards on these joints. So here are some images of the sewing that I was doing in the workshop. I didn't get any photos while I was actually sewing the text block itself. These are pictures while I was sewing the end bands. But it's a dual cord sewing, which is pretty standard from actually the 9th century to about the 14th and 15th century. In Northern Europe, you saw a lot of these double cords. And then in Southern Europe, they would sew on maybe alum-tawed straps or leather straps, but the actual stitching, this herringbone style stitch, was common throughout this period in all of Europe. So sewed on end bands were also common. Today, end bands that you see on books are just glued on in the production making process, but they used to be sewn. This is a bead on the back style end band in 2 colors, which is not necessarily period appropriate. It typically would have just been like an undyed, natural colored thread. In this photo, you see where we incorporated the end bands and the sewing cords into the wooden boards. After the cords and end bands are incorporated into the boards, they're pegged in with little wooden pegs, and then the pegs are snipped, and this is how tension is maintained on the cords so that they don't just slip out in the leather covering process. And then when I was doing research for this presentation, I found this really amazing database that was put together by Princeton University, and it's a database of 15th century bindings, I believe throughout a variety of North American libraries. So here I just have a couple examples of books from the 15th century, and if you look on the spine, you can see evidence of this dual cord sewing, and where the cords terminate as they're incorporated into the wooden boards of the books. And during this time, book boards were pretty much entirely wood, and they didn't become cardboard until much later, around the 19th century. And so, the purpose of these professional development grants is so that whatever knowledge you gain, you can utilize in your practices. So this is a gradual that we're working on in our lab right now. And understanding the anatomy of these books is really important for especially writing condition reports. So for example, when we were writing the condition report for this object, we were assessing how the cords had deteriorated, where they had been incorporated into the wooden boards. And we needed to be able to tell if the end bands had been laced in fact or not, and all these types of things. And so understanding what the book would look like if it was completely intact helps me understand what kind of damage the book is exhibiting today. I think I'm out of time, and that's all I have.
Well, thanks, Danny. We appreciate you. We appreciate you coming in and giving us that little rundown. That is part of the professional development grant is something we encourage everybody to take a look at. It's not just for students. It's something we can really help with being preservationists, something we can actually assist us in gaining knowledge. And we love having, especially seeing students come in and make use of those kind of things. So we're going to kind of shift gears, though. We are going to move into a discussion about environments and environmental controls. Amber and I were discussing how we thought this is a subject all of us are kind of interested in lately. Things that have happened in the state and then nationwide. The climate just keeps getting more interesting, and we keep having to solve problems that we didn't know we had to solve in the past. So we are hoping with these little short presentations, we have Kate Montlack and Victor Fleischer coming on to give us a little overview of what they're doing. We're really hoping that this encourages questions and discussion. We wanted to try to leave a significant portion for that discussion at the end of the presentations. So I encourage everybody to let us know what you're doing, and if anything twigs when you're talking to each other or hearing these presentations, please bring that up in the meetings. So I'd like to just go ahead and get into it. Our first presenter is Kate Montlack. She is the Director of Operations at the ICA and Art Conservation. I will let her take over, present her screen, and give a proper introduction.
Sweet. Yes. Hello. We, I think, have figured out a way to share my screen and also that I can see everybody, which is nice. Can you guys see my presentation there? Yeah. Okay.
Yes.
Okay, great. My name is Kate Montlack. I am the Director of Operations at ICA Art Conservation. As Director of Operations, I wear a number of hats. I am not a conservator. I am not a preservation specialist. I am the registrar. I am the person who makes the coffee. I am also the person who sort of handles client relations. And then I am also the person who's in charge of our physical space. So lots of different angles. I'm going to talk to you a little bit today about some chunky sludge. Very exciting, sort of seasonal. And what happens when you see chunky sludge coming out of your humidifier reservoir, and what you can do if you do. I know exactly, chunky sludge. Yeah, pumpkin spice, chunky sludge. A little tiny intro to ICA for anyone who's not familiar. We are a full service conservation lab in Cleveland. We work on artwork and cultural objects. And you can see I threw in a picture of Kate here. Here she is, working on a recent project. So we work on paintings, works on paper, textiles, objects. We're a staff of 9, and we were founded in 1952 in Oberlin. So we are currently, after being in Oberlin for a while, we moved to Cleveland. We were in a building in Cleveland's West Side for about 20 years. The pandemic hit, we decided to sell that building and move into a rental space, also on Cleveland's West Side. We are in a building called the Pivot Center. It is a repurposed light industrial building. It used to be a awning manufacturing facility. So an old building. When we moved in May of 2022, we were moving from our own building that had been totally customized to have environmental controls for both temperature and humidity. We were moving just 5 miles away, really, but we downsized about 10,000 square feet. So we have a much smaller space. We are in a rental facility. This is an old building that does not have a great envelope, and we were installing all of our own environmental controls into this space. So we worked with the architects and their engineers to develop, to put in place a system that we thought would work for us. But due to a number of factors and, timing, there was no period of commissioning for the space. So we were just moving in and crossing our fingers and hoping for the best. Almost immediately, we had extremely high relative humidity in the space. By August, we were seeing consistently in the 60s up to 70, sometimes reaching into the 80s. We were all very, very dewy most of the time. We were able to, work with because we were moving into a new space, we were still in touch with the engineers and the architects. So we were able to get some sort of assistance trying to troubleshoot. We were able to do an air balance test to make sure that was okay. We have our environmental controls for temperature are 2 10-ton rooftop units. So what the engineers found is that they were not operating with the sequence that had been spec'd out. So we were able to update that programming, get a little bit of a better control over our temperature. But as we were doing this, we were getting into the fall, and so humidity became less of a problem just through the change of the seasons. And then we were faced with a period of extremely dry conditions. Now, as part of our build out of our space, we had installed two dry steam XT series electrode humidifiers. I can give you the model numbers if you're interested at some point, but those were our wall mounted units in our lab space. They operate by feeding humidified air directly into the ducts that would serve, that are connected to our the rest of our HVAC. So they're basically sort of just spitting humid air into the ducts. So almost immediately when these kicked on in sort of late September, early October, we had a series of problems. First, the pump for the front unit, which you can see at the left here, was found to be undersized. And the way that we found that out was we walked into the lab one morning and there was boiling water running down the wall. So we had to turn the unit off, wait for a new replacement pump. Then our second humidifier, which you can see in the right, went out of service. It was leaking. We didn't know why. So there we were, it was December. We didn't have any humidification, not ideal. What we found for the second humidifier, the reason that it was leaking was that the reservoir bottle inside had cracked, and it was filled with this horrifying chunky sludge. So here you can see this technician who came out, who opened up this bottle and dumped out all of this disgusting silt. Here's some great pictures of it. It was thick and slimy and stinky. And it was also, I don't know if you can see it in the picture, but it was also chunky. So, so we were deeply horrified. The technician who we had working on our humidifiers said that never in 30 years of work had he seen this type of material come out of a humidification system. So that's great, just what you want to hear. So, and then here's just a close up of one of the chunks. And I have it here. I saved this. I don't know if you guys can see it, but here it is. It's like a little rusty alien spine. How exciting. So first we freaked out. We bought gallons of bottled water. We are on city water, just Cleveland city water. So we were like, what is happening? Like, is everybody being poisoned? What is going on? So it's not unusual to see a certain amount of scale buildup in these machines, especially if they're using city water. The technician told us we should look into some kind of softening to prolong the lifespan of the bottles. But we were told by the manufacturer that any sort of treatment of water going into the units would result in a void of our warranty. So we were in a little bit of a catch-22. So ultimately we did some tests on our water quality just to see what was going on, if there was anything that we needed to be aware of. Our water is fine. So anybody in the city of Cleveland, it's fine. It's a little bit hard, but not excessively so. No other contaminants that we needed to be concerned about. So by the time we sort of went through all of this, we were in kind of the last month or so of the warranty on these units anyway. So we decided, you know what, we're going to just go for it. And we installed some carbon filters to take the water from the intake, process it, and then send it into the humidifiers. That immediately seemed to resolve things. But at that point, we were getting to spring. So we didn't have that much humidification season left. And they have just, I would say we have just started up our humidifiers in the past couple of weeks. They've been working fine. I have not had them opened up to see what's going on inside, but I probably will be doing that in the next month or so, just to make sure that things are looking okay in there. And that is the saga of the chunky sludge at ICA.
Well, thank you very much, Kate.
Yeah, happy
We
to
appreciate
answer
that.
questions.
I'm, you know, once we get through, we get through Victor's, I'm very curious to know if you figured out what that was.
Yeah.
So, Kate, thank you again for presenting. Like I said, we're going to hold questions until the end. So next up is Victor Fleischer, and he is from the University of Akron.
Hello, everybody. Can you hear me? Great. Okay, let me see if I can share my screen. It worked earlier. There we go. Okay, everybody can see my presentation? Okay, great. So, yeah, great presentation so far. Love all the information, the rare books, the humidification. We actually have more issues with, we need dehumidification. So when I started at the University of Akron 16 years ago, my dean wanted me to look at how we could monitor and better control the environment. We installed some of the data loggers, the temperature and humidity monitors. And, you know, that's great for collecting data, but then I meet with our HVAC folks and there's not a lot of, not much we can do in order to control the environment. We're in a almost 100-year-old building, historic structure in downtown Akron, Ohio. It's an old, it's the Polsky building. It's an old department store. So the space is just so large and so vast. We have about 40,000 square feet of storage space and 40,000 cubic feet of material. So adding any type of humidifiers, dehumidifiers, whatever the case might be, we actually have some areas like our rare book area that is actually a little dry. But most areas are too moist because we've had a number of water infiltration issues that have just gone on and on over the years that we've been trying to address with capital planning and our facilities folks, but no luck so far. So, but there is hope. There is hope for the future. Anyway, so when the call for proposals went out, what I was thinking, the materials that I think are, at least in our collections, mostly affected by the environment are photographic media, mostly nitrate and acetate and polyester negatives and motion picture film. This is mostly going to focus on what we've done over the years and what we plan to do in the very near future to provide cold storage for our nitrate and acetate. These are things we can sort of provide micro climates to control. I start with these two images. They're not particularly interesting images, but I chose them because they show the level of degradation caused by environmental changes, not being able to control the large environment in our space. So on the left is an acetate negative from our Goodyear Tire and Rubber Company collection. So this shows one that has suffered from vinegar syndrome. I'm sure a lot of you have heard of vinegar syndrome. It not only off gases and provides that wonderful vinegar smell, but also is a telltale sign that those negatives are starting to deteriorate. And as this one, you can see to the point where it cannot be recovered. In fact, I've even talked with somebody at the ICA years ago, I can't remember who, that you know, I said, is there a way to kind of remove the emulsion from the base and try to save images like this? I would surmise it'd be incredibly costly, but you know, as far as they know, there's no way to conserve or restore these types of photos, except for scanning them and doing some work in Photoshop, which I'm becoming an expert at. But so with the environmental issues, the emulsions start separating from the base, they become embrittled, and you get shrinkage and cracking, unbuckling, unfortunately, the emulsions separating from the base. So that's the one on the left. Those are the major issues we have. And as some of you know, with color films, the image on the right is from our John S. Knight collection. I believe that's John Knight's granddaughter. Particularly the early color images are really susceptible to fading. And again, this all depends on your environment. Obviously, the colder the environment, the better for these types of media. The warmer and the higher humidity, you know, the more rapid degradation that we have with these types of materials. So what we did years ago was we applied for a National Endowment of Humanities grant to digitize and preserve our a large portion of our Goodyear Tire and Rubber Company negatives. There's somewhere between $500,000 and $1 million negatives. So the $303,000 only allowed us to do a small portion, about 23,000 images, everything from the founding of the company in 1898 through 1951. We picked that as a cutoff date because we wanted to identify the nitrate still images. So our acetates, we didn't have the funding to create a cold storage room, which we plan to do in the future, hopefully. So the economical approach is to purchase for acetates. It's these freezers. They're upright, frost-free commercial freezers. These ones I like because they have the digital thermostats or thermometers on the outside, so you can check and make sure that the temperature is not rising, or if it is out, which happened in one case that you know, we had an issue with the failure of the product, and fortunately it was under warranty and the company replaced it. But we purchased these from a company called HPS. They're commercial freezers that are mostly used in the food industry. At the time they cost about $1,300. Now this was before the pandemic and inflation, so I assume they're up a little bit now. And the nice thing about these, they can be plugged in the standard electrical outlets, although we had to have additional outlets installed in an electrical upgrade. As far as the nitrate still images, we store all of our nitrate motion picture film off campus. Our health and safety folks prefer that. There's not many storage vaults out there anymore that are willing to take nitrate still images or motion picture film. So our nitrate still negatives we store in these 20 cubic foot, they're frost-free, explosion-proof hazardous materials freezers that we purchased from Fleischer Scientific, company that we use on campus to purchase products like this where they store chemicals in like our chemistry lab. At the time, these were about $3,000. They do require hard wiring. There's no standard plug. Done by professional electricians. So our electricians on campus were able to do this work. The nice thing is the grant funded the purchase of all these products as well as the electrical work. So these in particular are tied into, they have their own electrical panel and our own generator that's on the roof of our building. So in case of power loss, there will not be loss of power. The generator will kick in. There won't be loss of power to our nitrate and acetate freezers. So the negatives, whether they're nitrate, acetate, polyester base, were digitized. You always want to digitize them at high res, save them as TIFFs for your master files before you put them in cold storage. We rehouse them in acid-free envelopes, labeled them acid-free boxes that pass the PAT test, labeled everything with information. So to minimize handling and make retrieval a little bit easier. The hope is that once you digitize them and put them in cold storage, you won't have to access them. Unfortunately, we found out there's been issues where we had to access them infrequently, but one issue was an error on the case of the vendor where the image is a set of images were scanned at low res. So unfortunately, we had to go back in, find them, remove them, let them acclimate, and redigitize those. And we also had another issue with some of our drives going corrupt. So let's see. The National Park Service has a great website and one of those conservograms that talks about how to properly do this, putting them in Ziploc, polyethylene, and polypropylene bags, putting the boxes in there, the vapor-proof double bags, to prevent moisture from penetrating the boxes. We also put these humidity indicator cards in there to help us kind of monitor the moisture within those microenvironments. We inventoried all the freezers again, so we know what's in them and to help with retrieval. All freezers are maintained at a constant 0 degrees, plus or minus 1 to 2 degrees. From what I've read, the colder, the better. I don't think you want to go below 0, but the colder you go, the longer you extend the life of the material. However, that increases costs with energy consumption. So the pros of this type of cold storage, obviously very economical. They're easy to implement. My staff and I were able to do this with a little assistance from our physical facilities and electricians. They don't take up a whole lot of space. There's good instructions out there. I have a slide here I'll share with you in a minute. National Archives, National Park Service provides great instructions for how to properly store, wrap these, how to store them in the freezers and monitor them. The negatives are, again, if you have to retrieve them, they recommend taking 24 hours. It could take up to 24 hours to acclimate the material before you remove it from the boxes and access it. Freezers can stop working. As I mentioned, we had that issue at least once since we've had these. So they need constant monitoring and sometimes repair or replacement. And as you can see from this image, even though they're frost-free, the freezers can still build frost, which means we have to remove the material, hopefully put it in a freezer that is empty, and we do have one of those, and then we have to defrost it and then plug it back in and repack it. So our future plans, what we'd like to do, these work great, but even the National Park Service recommends if you have 10 freezers or more, and we're getting to that point, it's better just to build a true cold storage room. So that is our hope. I found this image online from the National Archives. This is what we'd love to do. I think Ohio State has one that they keep at about 55 degrees. Again, the colder, the better, but energy costs. So the university received a $20 million grant from the Knight Foundation and $20 million in additional matching funds to renovate the Polsky building. Now, not all of that money is going to come to the archives. We're hoping to get a small portion of that. But one thing that we hope to do is to build a cold storage room. And this will eliminate the need to constantly monitor the freezers, allow us to store hopefully all of our nitrate and acetate, polyester negatives, and motion picture film. Depending on size, I estimate it's going to cost about $150,000, maybe more. So we'll see how much of that 40 million we get. So these are just some of the resources that are out there online that tell you how to do this properly. The conservogram from the NPS is the best resource. So I'm sure I'm over time.
Just a hair, but it's fine.
Okay, all right.
Victor, thank you very much. I'd like to thank all of our presenters, Daniella, Cade, Victor, and thank you so much for those great presentations. I would right now like to open up to questions. I see a couple raised hands on the chat, so let's go. I'm just going to go first to last. Jill, if you'd like to ask your question.
I don't really have anything. I actually was just putting in the chat that I have a minor crisis going on, so I have to leave.
Oh, well, then, by all means, don't let us keep you.
Okay, thanks.
Jim, you had something?
Yeah, just a quick question for Kate. Why did ICA move out of a building they owned into a rental?
So it was all really it was a combination of reasons. First, I think primarily pandemic related. So our basically business tanked for us during the pandemic. We felt like the building that we were in, which had been sort of customized and built out all of the HVAC systems were about 20 years old at that point. So it was a balance of, do we at this point try to bring them, invest in them, or do we offload the building, have a little bit of money for an endowment, move into a smaller space, and carry on and go in that direction. The building that ICA was occupying is in a really kind of hip neighborhood in Cleveland, so the real estate market was good. So it was a completely practical decision. And there's our director says, and also there was no parking.
Yeah, the other thing too is that since
Jamie can tell. Yeah.
One other thing with that building was that there was a huge storage space.
Right.
And it was really causing a lot of we weren't really making enough on the storage to justify having to keep the environmental controls required to have that storage. And so that, like Kate said, it's really a practical kind of decision.
Yeah. And I think it had been, I've only been at ICA for about 3 years, but I think it had been kind of a long time coming, as
Okay, thank you. Moving on, next question is Matt.
Hi, thanks. Really enjoyed all the presentations. I just have a small question for Victor. I was at Digital Transitions Fall Roundtable in San Francisco last week, and San Francisco Museum of Modern Art was presenting about their recent cool cold storage implementation. And so they do, when they take stuff out of their cold storage, which I think they have a lot of negatives, but primarily it's color prints. You're dealing with some of the same issues, but they do a step down from out of truly cold into a cool room for 24 to 48 hours before they open anything. I was just wondering if that's part of your thinking or planning for when you might implement your true cold, or if anyone else is doing anything like that.
Yeah, good question and good suggestion. Yeah, at this point, based on lack of funding, we don't have a cool room. Yeah, that is what's kind of recommended, is getting into from the freezer, a cold storage to a cool storage to let it acclimate. We don't have that, but that's a good suggestion, something I'm thinking about. If we get the funding to create a true cold storage room, then also having a cool storage room where things can acclimate, or things like prints that might not have to be stored at 0 degrees, but maybe 32 to 55 would be ideal. So again, depends on how much of that 40 million trickles down to the archives. So
absolutely.
Pie in the sky ideas, and this was one we had that we'd love to do. That's at the top of our pie of the sky list. But as I told them, really just fix the leaks. And I'd be happy. So.
Yeah, absolutely.
Yeah, good question.
I see another question. Gina?
For Kate, I was just curious of the sludge, is it just this is gunk that built up from the water that's not that bad when it was tested?
We didn't test it. We just don't have that capacity internally. And when we tested the water and found that there was nothing alarming, we were like, it's probably just, we sort of were like, well, I guess it's okay. But I did, we were just actually, Kate and I were just talking before, because I did save this little chunk here. We later found that it's magnetic, right? This little piece. So it's obviously there was some metal, iron, it would have been really interesting, and it still would be, to get some analysis of what exactly that was. And I think it's, the buildup of whatever is typically makes water hard, just to an extreme degree. I have nothing more scientific to tell you, which I wish I did. It would be really neat.
Cool. Well, thanks.
Yeah, sure.
Yeah, to sort of chime in and seemed organic to me, like in some
For
kind of
sure.
composition type, especially describing the smell. But,
Yeah.
I mean,
Which
how would
is-
that have gotten in there? You know,
Right.
Is
I
that a
know.
little-
I know. And that's what our technician said as well, who was really fantastic. It, you know, it had that sort of slimy quality. But again, the water there was nothing alarming in our testing of the water. So we were sort of like, well, let's see what happens. And so the carbon filters seem to be working. You know, we haven't seen any issues since starting that kind of filtration. So, you know, we'll see. I mean, maybe down the road we'll be able to get some analysis, but so far so good, you know.
Victor, jump in.
You have a couple questions for Kate, but I was just thinking as you were talking, could it be the pipes? Because it almost looks like
It might
rust.
have
That
been.
would-
You know, but this is the building that we are in now. While it is an old building, it's a little bit over 100 years old. All of the mechanicals are new. So it was a developer who basically gutted the entire space. So and that was another thing that we thought, like, is this some kind of, you know, it's new pipes, maybe it's like a residual
Oh, right.
gunk
right.
or something. But it was, I mean, the quantity was such that we were just taken aback. If it was, the buildup was so much that it, you know, as I was saying, cracked the internal canister of our humidifier. It was so solid and so heavy. So it maybe it was, you know, so a little bit of A and a little bit of B.
Hard to tell. Yeah.
Yeah.
So I'm kind of surprised that you have humidifiers instead of dehumidifiers. So it sounds
You know,
like your environment.
we have dehumidifiers in the summer. So we
Oh,
just are
okay.
switching over in our seasons, right? So because
I see. Interesting.
like you were in this old building, the envelope is not great.
Right.
So we are constantly in this
I
trying to
see.
strike this balance.
Okay. And is that for the entire facility or just
Yeah.
certain rooms or areas? Wow. Okay.
For,
'Cause like I
yeah,
said, we have 40,000 square feet, and we were told by our HVAC folks that whatever you do isn't going to touch that space. If we need, you know, I'm like, can't we just get industrial size humidifiers? It's like, it's not going to touch the space. Now, I don't know if they're just feeding me a line of BS because they don't want to do
right,
it, or, you know, or that's really true. And, you
Yeah.
know, like they said, to create a cold room or to truly control the environment like they do in computer server
Right.
rooms is going to be about $150,000. So
it's expensive. It's
Yeah.
expensive ever.
Victor,
for
I
your
can,
unit. Oh, sure.
I can speak to that a little bit too. You know, Kate, we also here at Miami, I have sort of three major areas of special collections and archives. We have 2 temperature controlled rooms, a vault, which is biometrically locked with all of our super valuable stuff in it. We have a cold storage, and then we have our sort of normal area. And in the normal area that is controlled by the building HVAC, we have a lot of trouble maintaining humidity either end of the spectrum. I'm down as low as 15% and up as high as 55% sometimes. So trying to navigate that is challenging.
It's a dance for sure.
Yeah.
And so I think that'd be you know, our stack area is kind of one big area, you know, but it'd be great if we could compartmentalize and, you know, our rare books are in one room, or, you know, motion picture film and negatives are in one room, and, you know, and then we can monitor and control the temperature immediately a little bit better. Again, it depends how much of that money we get. I don't have high hopes we're going to get a lot. So.
Does anybody else in the chat have a question for either Danny, Victor, or Kate while we're wrapping up here?
I just have a comment.
Jim, go ahead.
So I have experienced my last job where there was a cold vault that was installed in probably the 2000s, and essentially it was a walk-in meat locker. And the original systems had failed. They had issues with mold outbreaks, and also there was a drain right in the middle that basically backed up. So it was water that would back up into the space, and it wasn't really monitored. And when when the building was renovated, I was like, okay, we really need to like rethink this. So we had a new floor poured. We ripped out all that old gear and had a Munter system installed in the space next to it. Because my whole thing was like, we got to get the equipment out of the room and basically having, everything be segregated out. The problem was that we didn't replace the vault itself. They kept the original panel. So when we finally got it online, I would go in there pretty much every day and it was sweating. So there was like, it wasn't a big deal, but there was condensation happening on the inside. And I think if you're building it from scratch, you have it much better, because then you could put a vapor barrier on the floor and in the walls. You'd be starting out in a much better situation. But I think there was a Munter's solution provider in Northern Kentucky that we worked with. I don't remember the exact details, and then also we were able to like really dial in temperature and humidity. But the only other drawback was having a separate staging area for acclimatization. So like if you're gonna build like just like with the nitrate and the acetate film, you have to have a staging area. So, but those are just my feedback on that.
Good to know. Great information. If we get the funding to do it, I think I'm going to be calling you, James. So maybe we can hire you as a consultant, and you, Eric. So
shoot, I got to get it figured out first. Okay,
yeah.
So we have. I'd like to. We'll do one last question. Sarah's got one last question. I'm going to say right now, thank you, Victor. Thank you, Danny. Thank you, Kate. Sarah, let's have your question. After Sarah, you're done. Jim, why don't you pop on and close us out? Okay.
Hi, I wasn't really going to have a question. I just wanted to put out there that I have worked at 2 museums in the past that have both had cold storage. One was the Amon Carter Museum of American Art in Fort Worth, Texas, and I was there from start to finish with their entire cold and cool vault renovations. And they also had 3 of those standalone explosion-proof chest freezers for their nitrate negatives. They were not frost-free, so they had a monthly check and a quarterly to annually defrost schedule. And we would take the things out to defrost, and they could sit at room temperature because they were double bagged. So any condensation would form on the outside of the second bag that all of the boxes were bagged in. The other museum was the George Eastman Museum in Rochester, New York. And I wasn't in their motion picture department, but they have cold vault for all of that as well. So if anybody has cold storage questions, we do not have dedicated cold storage here at Ohio State, but we do have cool storage. So you can get at me. I will have lots of answers for you.
Thanks, Sarah. Yeah, ours are double bagged as well, so maybe it's not as you know.
I saw.
Yeah.
But,
well, I'm just going to say thanks everyone for what a great, fantastic panel. Thank you to Amber and Eric and Victor and Kate for agreeing to participate. I think it's been very, very lively, and hopefully people have something to take away from it. Black sludge. So anyways, yeah, thanks everyone. And we'll see you next year at the next quarterly meeting. All right, take care.
Thanks everyone. Have a great day.